Have you ever looked up at the night sky and wondered what's out there? Sure, we know about Mars, Jupiter, and all our planetary neighbors. But what if I told you there's a planet out there made of pure diamond, a shimmering, glittering world that would make any treasure on Earth look like a pebble? Sounds like something straight out of a science fiction movie, right? Well, stick around, because today we're re-diving into the dazzling reality of a planet nicknamed the Diamond Planet, 55 Cancri E. First things first, where is this cosmic treasure chest? 55 Cancri E is located about 41 light-years away from us, in the constellation Cancer. Now, 41 light-years might sound incredibly far, and it is. If we were to travel there with our fastest spacecraft, it would take hundreds of thousands of years. But in the grand scheme of the universe, it's practically in our cosmic backyard. This planet orbits a star named 55 Cancri A, which is part of a binary star system. So, imagine having two suns in your sky. 55 Cancri E is what astronomers call a super-Earth. This means it's a rocky planet, like ours, but much, much bigger. It's about twice the size of Earth in diameter, and has 8 times the mass. But what makes it truly special isn't just its size. It's what it's made of. And to understand that, we need to talk about its crazy environment. This planet is incredibly close to its star. How close? It completes a full orbit, its entire year, in just 18 hours. Let that sink in. Our year is 365 days. Its year is less than 1 day. Because it's so close, the temperatures are absolutely scorching. The side of the planet permanently facing the star can reach temperatures of around 2,400 degrees Celsius, or 4,400 degrees Fahrenheit. That's hot enough to melt most metals, including steel and titanium. The dark side, which always faces away from the star, is still incredibly hot at around 1,100 degrees Celsius. So, where do the diamonds come in? The initial theory that got everyone excited came about a decade ago. Scientists looked at the planet's mass, size, and the chemical composition of its host star. The star was found to be rich in carbon. Since planets are formed from the same disk of gas and dust as their star, it was logical to assume that 55 Cancri E would also be carbon-rich. Now, think about how diamonds are formed here on Earth. They are created from carbon under immense pressure and high temperatures deep within the Earth's mantle. So, the hypothesis was born. With its massive size creating incredible internal pressure, and its proximity to the star providing intense heat, a carbon-rich planet like 55 Cancri E could have a crust and mantle made of graphite and a thick layer of pure diamond underneath. We're talking about a planet where a third of its entire mass could be diamond. Imagine that. A diamond layer thousands of kilometers thick. This idea captured the world's imagination. A diamond planet. The headlines were spectacular. It was the ultimate cosmic treasure. But as with all great scientific stories, the plot thickened. Science is all about testing theories. And as we gathered more data, the picture of 55 Cancri E started to change. More recent observations, using advanced telescopes like the Hubble and Spitzer space telescopes, allowed us to analyze the planet's atmosphere as it passed in front of its star. This technique is called transit spectroscopy. By looking at the starlight filtering through the planet's atmosphere, we can detect the chemical elements present. What did we find? Surprisingly, the initial atmospheric readings detected hydrogen and helium, but not the massive amounts of carbon we expected. This led to a new wave of theories. One leading idea is that 55 Cancri E isn't a solid, carbon-rich world, but a planet with a thick, steamy atmosphere. The extreme heat from its star could have boiled away its original surface, creating a dense atmosphere of vaporized rock. Instead of walking on diamonds, you'd be flying through a fog of molten silicate. This world might have a dynamic atmosphere with lava raining from the sky. So, maybe it's less of a diamond planet and more of a lava world. Another fascinating possibility is that the planet has a sort of day-night atmospheric cycle. The intense heat on the day side could melt the surface, creating oceans of lava. This lava would then evaporate, forming a rocky vapor atmosphere. Winds could then carry this vapor to the cooler night side, where it would condense and fall back to the surface as lava rain, flowing back towards the day side to complete the cycle. It's a weather system unlike anything we have on Earth. So, is the diamond planet dream over? Not entirely. The truth is, we're still not sure. The interior of an exoplanet is incredibly difficult to study from 41 light years away. While the surface and atmosphere might not be what we first thought, the high-pressure, high-temperature conditions in the planet's mantle could still be perfect for forming diamonds. It's possible that the core is surrounded by a massive diamond layer, hidden beneath a silicate crust and a thick, toxic atmosphere. The diamonds could still be there, just buried deep inside. The story of 55 Cancri E is a perfect example of how science works. An exciting hypothesis is proposed based on the available data. Then, as new technology allows us to gather more information, that hypothesis is tested, refined, and sometimes even overturned. We go from a simple, elegant idea, planet made of diamond, to a more complex and, frankly, more bizarre picture of a world with lava, oceans, and rock vapor clouds. Whether it's a diamond world, a lava world, or something else entirely, 55 Cancri E remains one of the most fascinating planets ever discovered. It pushes the boundaries of what we thought was possible for a planet's formation and composition. It teaches us that the universe is far more diverse and strange than we can imagine. And who knows what we'll discover next. With new technologies like the James Webb Space Telescope, we're getting an even clearer view of these distant worlds. We can analyze their atmospheres with unprecedented detail, searching for the building blocks of life or uncovering planetary environments that defy our expectations. Each new discovery, whether it confirms or challenges our ideas, brings us one step closer to understanding our place in the cosmos. The quest to find out the truth about 55 Cancri E is still ongoing. It's a cosmic mystery waiting to be solved. And maybe, just maybe, deep beneath its scorching, hellish surface, the universe's greatest treasure is still waiting. So, what do you think? Is 55 Cancri a giant diamond, a seething lava world, or something in between? Let me know your thoughts down in the comments. And if you enjoyed this journey to one of the craziest planets in the galaxy, don't forget to hit that like button and subscribe for more adventures into the cosmos. Thanks for watching, and keep looking up.